Okay, so already did 11. Let me go ahead and do 12. An electrical motor provides a 0.5 watt mechanical power. Okay, so that's going to be P equals 0.5 watts. Okay, and let's see, how much time will it take? So we're going to be looking for time. The motor to lift, okay, we're going to have a mass is 0.1 kilogram, okay, at a constant speed, so that means your acceleration is 0, it's just at a constant speed. Not going to have a change in kinetic energy from a shelf 2 meters above the floor, so we have a height, which is 2 meters. Okay, so basically what you're going to have here is a power equals a change in energy. In case you haven't noticed, MH, MGH, I'm going to say a change in potential energy over a change in time. Therefore, time equals potential energy, which I'm just going right out, GH over power. So that's going to give you, I'll try to do this as the fractions. It's going to give you 1/10 times, because that's this is 0.1 kilograms, a tenth of a kilogram, times 10 times 2 times, okay, wait a second, 2, that's your height. Power is watt, that's 1/2. We're going to flip that over, times 2. It's going to give you 4. So 4 seconds, E. The answer to 12 is E. Alright, so 13 is just a different color. The block slides from rest. Okay, so that's its height right there. Alright. Okay, so there's no friction here. So here there's no friction. There is force of friction here. Draw it scratchy. Okay, block slides from rest with negligible friction down the track above. It descends, falls down a vertical height, 0.05 meters to point P at the bottom. Then slides on the horizontal surface, which is rough. The coefficient of friction between the block and the horizontal surface is 0.2. How far does the block slide on the horizontal surface before it comes to rest? Okay, so the way I would look at this one is you basically want to see how much work the frictional force does on the block to get it to where it comes to rest. Alright, and you don't know how far it's going to go. So, but remember, so you wouldn't want to use like force times displacement, but remember, work is also a change in energy. Alright, so in this case, it would be a change in, well, if you look at it from right here, because we've got like potential energy to kinetic energy to nothing. Alright, so it's just going to be the change in energy of your system, because your system pretty much ends. So all of your energy is getting lost to friction, if you think about it that way. So therefore, MGH is going to equal your work. Okay, so that's going to be mass. What was your mass? Oh, you don't have your mass. That's a problem. So, but look, all of that gets converted into kinetic energy, right? Okay, so, oh, I forgot